Hello, in this video we are going to discuss about the other deep learning algorithm, that is CNN, whose full form is Convolutional Neural Network. Before going on to this, let's try to understand what kind of data that we have used till now in the problems that we have solved. If we carefully observe, the data structure will look something like this. We'll be having multiple features like feature 1, feature 2, so on, feature n. So based on all these features, we'll be having some corresponding output like y. On the input features that we have given, we need to predict the value for this particular y. And then we'll be having several data points in the same format. Like for feature 1, we'll be having some corresponding value x1. For feature 2, we'll be having corresponding value x2. So on, followed by feature n, where we'll be having the corresponding value xn. So for all these input values, we'll be having corresponding y1. So this is the kind of data that we have seen, and we know what we call it as, that is a data point, and we'll be having several such data points which will combine to form a data set. All these things we already know, and we have solved every problem on such kind of data sets only. But if you see some real-time problems, there are so many other kinds of problems as well, right? Where you might need to deal with images, or sometimes you might need to deal with video, or sometime you might need to deal with audio, or you might need to deal with pure text. So like that, there are so many other forms of data. We are very interested in image kind of data in this particular video. So let's try to explore these images from now. So we have seen how we can work with tabular data from last few videos or many videos from the starting. Now let's go and explore images. Later we'll try to understand whether how to deal with video, audio, text, all these as well. Okay, in the future videos maybe. Let's continue for now. So as I said, if we are having some tabular data, then what we are doing, we are trying to use, or we are trying to feed these features to a ANN, that is our artificial neural network, right? How we'll be doing that? We'll be sending feature 1, feature 2, feature 3, so on, feature n in the input layer, followed by we'll be having some hidden layers. These hidden layers can be as many as possible, and it is up to us. That means that these are all hyperparameters. By having multiple hidden layers, we'll be having some output layer as well, through which we'll be getting the output. So this is the network structure that we have discussed in case of ANN. But do you guys think in case of images, can we use the same ANN structure? So please comment down your answer. I hope you have commented down your answer. Now let's see what is an image look like. Basically, if you think of an image, it is just an array of pixels or matrix of pixels. So let's say in this image, there is a person, there is a boy, small boy, who is looking like this. And if this image is representing this boy, that means that in this portions, the pixel value is higher, so that it can represent the color, how he looks like. Okay. So by changing the intensity of the pixels, okay, or in general, the pixel values will range from 0 to 255. By changing these values from 0 to 255, it is able to show the picture that it is shown over here. Okay. For now, for simplicity, let's take it as some black and white image. And in case of black and white, this color intensity represents how much white it is or how much black it is. Okay. So that is what it represents. And because of the intensity of the black and white color, we are able to picture this particular image. That means that image is nothing but an array of pixel values. Okay, so you can think that all these were filled with zeros, and only in the portion where the image is there, image of this small boy is there, in that portion only we'll be having some numbers like 10, 1, 11 or 15. some numbers will be there which will sum up and form this particular image visually. That means if we are dealing with image, that means you are simply dealing with these numbers. Instead of these features, now what we'll be having? We'll be having these numbers. So that is the only difference. That means that we can simply use this ANN for images as well. But do you guys see any problem with this? So the main problem is like here images are of varying sizes. So if you think of images that you are taking it on your phone, nowadays the phones that you are getting are of 50 megapixel, 100 megapixel and 200 megapixels. Like there are various mobile brands which are providing you such high-end cameras, and through that you will be having like very large sized images which will be maybe like 2048 cross 2048 or even larger for suppose. Then like that means that there are these many number of pixel values that are present. Okay, so if you are having these many number of pixel values, that means that you need to give these many number of inputs to the ANN, which leads to, like, let's say there are 2048 into 2048. And what is this 2048? This is nothing but 2 power 11 cross 2 power 11, which multiplies up to 2 power 22, which is very large number. And this 2 power 22, let's say it is getting multiplied with some thousand number of neurons in the hidden layer 1. That is 2 power 22 cross 2 power 10, which is 2 power 32. And this is the number of weights that we have in one layer, right? So if we are thinking about like the task that we are trying to solve might be very simpler task, like if we wanted to do binary classification between two persons and you wanted to identify whether it is a person A or person B, that is really a very simple task. We are having only two persons and we just need to identify which person it is. For such very small task, we are trying to have these many number of parameters, and this is not at all good. So that's why it is not preferred to use ANN in case of images, as it is unnecessarily increasing the number of parameters that we have, right? That's why we are going with some other type of architecture where we can extract out important features from the image and we try to play on it, okay, and then finally get the output that we wanted. Here if you observe, if you are taking an image of persons, then what can be the possible features that you can think of? So let's say this is the image that we are having. Then for this image there are so many multiple features that we observe with our naked eyes. So those features are like eyes, nose, this mouth, this hair, this ears. Like this is the way we observe or we identify an individual, right? So we see his features, like his eyes looks like this, his face looks like this, his mouth looks like this, his lips look like this. Based on those features we are able to identify that this is a person A or this is a person B. That is what we try to make the model learn, that these are the features and you need to identify that, or you need to map that this feature is correspondent to person A. And in person B image, there he might be having ear little bit in different shape, and this feature is correspondent to person B. This mapping needs to be done by the model. If we can tell that this is the feature that model needs to identify, then model will be easily doing that, right? So instead of concentrating on the whole image that we have, if we can concentrate on the smaller features or smaller subparts of the image, that will really help us. Okay, so here if you observe, we are trying to concentrate on the whole image if you're passing the image directly to the ANN. But the idea of CNN comes over here, where we are not trying to give the whole image, or we are not trying to give each and every part of the image, whereas we are trying to give only specific input features that we are interested in. By giving these input features, we are trying to able to tell whether it is a person A or person B. So this is the basic idea of CNN. I hope you guys understood. The problem with using ANN, that is, there are too many parameters. In CNN, how we can solve this problem? By just extracting out features. In CNN, we do extracting out features before directly passing this whole image. Whereas in case of ANN, we just pass the image as it is, or we just give all the pixels as the inputs. So which leads to too many number of parameters. Whereas in case of CNN, first we try to extract out all the features from the input image, and then we'll feed it to the model, which will be giving us the corresponding output with lesser number of features or lesser number of inputs. So I hope you understood why using CNN in case of images is better. So that's it for this video. If you have any doubts, please comment down in the comment section. We'll see you in the next video. Thank you everyone. Bye bye.